We're learning about ecological pyramids today. This is your Eco 5 note, if you'll go ahead and find that in your lab notebook. So ecological pyramids are models. Now, this is not your lab notebook. This is just a little bit of information to help you with having a little bit of background about ecological pyramids. So, of course, they're going to be representing something about the environment because we know eco means environment. So they are generally showing how energy is going to flow through an ecosystem. You may have trophic pyramids that are showing you about energy or biomass or about the number of organisms that live in an environment. So there's several different ways to present information or data about an ecosystem. The base of the pyramid is going to be producers. So if you look down at the bottom of the pyramid here, you have the producer level, and you can see in this ecological pyramid that the producer level is the largest, and that's generally the case, but it's not always the case, but most times you have the producers as the largest part of the pyramid. So then the ones that you have above that are going to be consumer level. So the primary consumer is going to be the herbivore, so that's the organism that eats the producers, which producers are generally going to be grass or algae, that kind of thing. The secondary consumer will eat the primary consumer, and the tertiary consumer, in this case, is the apex predator. So that's going to be whatever's at the top of the food chain, and the tertiary consumer will get its energy and food from the secondary consumer. So this is on your notes, energy pyramids. So energy pyramid is first representation of a trophic level pyramid or an ecological pyramid. So this is of course going to represent energy. It's the energy that is available in the ecosystem for each of your trophic levels. Now in this energy pyramid, you can see that the energy from the sun is what is providing the energy for this ecosystem. That's the case with most ecosystems on Earth. The sun is going to either directly or indirectly provide that energy. So the energy is being passed up the food web, up this food pyramid, and you can see that off to the side here, it's showing that energy is lost. So energy is going to be released in a variety of ways. Energy is used by organisms for moving around, for digesting food, for doing all the things that you do every day, for thinking even. So this is the 10% rule. And this is really important because on your EOG, you'll probably have specific questions about this. So if you notice the numbers here, in this energy pyramid, you start out with 100% energy. So that's your base level of energy that you have, 100% straight from the sun. So the primary producers, or just the producers, have the largest amount of energy that is available. So 10% of the energy passes up to the next trophic level. So 10% of 100 is 10%. So that's why you have this number here. 10% of 10% is 1. So that's this number here. 10% of 1 is 0.1, and 10% of 0.1 is 0.01. So the reason why it's called the 10% rule is because only 10% of the energy available at each level is passing up to the next level. So what happens to the other 90%? It gets lost, it gets consumed, it's used in some way. Like I said just a minute ago, digesting food, moving, running, thinking, hunting food, doing everything that you need to do every day. So the energy needs of organisms are going to be greater from one level to the next. So this guy up at the top, this hawk, falcon, eagle, whatever kind of raptor or bird of prey this is, needs the most amount of energy. So it's going to have to consume a lot more than like the rabbits down here would have to in order to have the amount of energy that it needs for its daily consumption. Each level in a trophic level pyramid or in an ecological pyramid can support fewer numbers of organisms than the one below it. And that's because of the amount of energy available. That's why we were just talking about the 10% rule. So you can see the 10% rule reflected here. 100 to 10 to 1 to 0.1. And you can see this pyramid only goes up to a third level consumer. It doesn't have a quaternary or a fourth consumer like the previous example did. So about 90% of the energy in an ecosystem or in a trophic level is going to be lost to the environment. That loss is consumption. It is energy that is used due to growth and reproduction, repairing cells, homeostasis, digesting food, moving, all the things we were just talking about a few minutes ago. So you can see that represented in this 90% of loss over here. Numbers pyramid. So this is the next example of an ecological pyramid. So a numbers pyramid is going to represent the amount of organisms you have available at each trophic level in an ecosystem. So this is going to be looking at populations and seeing how populations compare to one another. So down here, this is showing you 11,977. That's your producer. These are aquatic plants. The next level up, so these are going to be your primary consumers. These are caddisfly larvae, which are these cute little bugs over here. Those are eaten by the bluegill fish, which you see in the secondary consumer level. There's 316 of those in this particular habitat. And then the smallest group, but the largest organism that needs the most energy is going to be the 13 largemouth bass that you have in this particular habitat. So this numbers pyramid is just showing the amount that you have available in a specific population in a specific habitat. So the autotrophic level is going to be your producer level, and generally they're going to be the largest amount of organisms that you have. So in this example, you have 5 million producers available. You got lots of these grasses and other types of plants. And then you can see things get the amount of those organisms get smaller as you go up. But one thing that I think is interesting is the organism itself generally is going to be getting larger. So you can see up here we have the largest organism, but it represents the smallest population, only 5 of those tertiary consumers. Same thing down here, over 5 million in population of producer, and then drastically gets smaller and smaller. So the total number of individual organisms tends to decrease as you go up in trophic level. So you get fewer and fewer of those organisms as you go up the pyramid, in the numbers pyramid. And then the last one is a biomass pyramid. Bio! So what's bio mean? Bio means life. So biomass pyramid is going to represent the total mass of the living organic matter, or recently living organic matter. So that is looking at each trophic level in the ecosystem. So in this pyramid, in this biomass pyramid, the bottom one, we have our producers, and that's approximately 3,000 grams per meter squared. Looks like it's 2,880 exactly. So the primary consumers, the fish that we have here, 675 grams per meter squared. So you can see again, the number is getting smaller and smaller, so the biomass that's available is getting smaller and smaller as you go up in the biomass pyramid. So the number of organisms is going to be reduced. It gets smaller as you go up each successive layer or trophic level. The biomass is also going to reduce. So since you are getting smaller and smaller in the amount that's available, you're getting smaller also in the biomass that's available, because the biomass is just literally looking at the mass, the weight, the amount of the living organic tissue and organic matter that you have available. And also the biomass may include things that are recently deceased or parts of living organisms that are going to be part of the organism, but maybe something you don't necessarily want to eat, like a bird's beak, for example. So a bird's beak would be included in biomass because it's organic matter. It's part of that bird, but you wouldn't want to eat it. So even though the biomass pyramid shows the total mass of the living organisms available, doesn't necessarily represent the amount of energy that's available. So you might have some chicken fingers, but you're not going to have like some fried chicken beaks. Maybe you would. Probably wouldn't be good though. So another example, like in the ocean, might be coral. Well, some organisms might eat the soft coral tissue, but wouldn't want to eat the hard outer calcium carbonate skeleton of the coral. That wouldn't be tasty.